Thank you everyone for joining us today to talk about real-time data. We often hear that real-time is a myth or it's not necessary, but we'll walk through 3 real-world scenarios for real-time to dispel that myth. There is a question queue. If you'd like to ask us a question, please do so there to minimize disruption, and we're going to save those for the end. If we don't get to your question today, don't worry, we will follow up with you after the session. So just drop those in that question queue. I'm Erica Fowler, Product Marketing Manager for Molecula. I've spent the last 12 or so years in strategy and analytics across various industries. I also have a PhD in epidemiology, where I discovered my love of data and analytics. I'm here with my colleague, Albert Traylor, Senior Product Marketing Manager at Molecula. Albert?
Thanks, Erica. So I have spent the last 6 years of my career in product management and product marketing roles within IBM. I've been in both their cloud and data divisions, and now I'm with Molecula, where I can continue my love of data and analytics and creating products and brands that make end users' lives easier. So Molecula was created from a challenge in customer segmentation. With a database of billions of consumers and hundreds of millions of attributes, traditional Elasticsearch and Cassandra instances didn't work. The CEO of a predecessor company to Molecula challenged his engineering team to solve the problem through a new format. That format came in the form of what is now FeatureBase, which extracts the relationship between the underlying data and allows for real-time data computation that's orders of magnitude faster than before. And with that, Molecula was born. So just a quick definition, Molecula closes the gap between data and decision, enabling organizations to unlock the power of real-time analytics and AI. By eliminating resource-intensive pre-aggregation, Molecula accelerates data-driven innovation. So with that definition in mind, I'd now like to welcome our special guest, William King, the CTO and co-founder of Subspace. William, can you dive into your background a little bit?
Hi, folks. Glad to be here. Thanks for the invite. So co-founder of Subspace, where we're building global real-time communication networks. My background goes for the last 15, 20 years on how to be able to build systems that span the globe and are actually real-time and letting people communicate in the same machines. So Subspace is building the fastest global network for games, voice, video, and other use cases. And for us, we say every millisecond counts.
Thanks, William. It's great to have you join us today. We have a fun session planned. We'll define real time to get everybody on the same page, and then we'll go through 2 real-world examples for how our customers are using real-time data to power their business. And then we'll do a deeper dive with William to talk about how Subspace is using real-time data to build the world's fastest internet. Finally, we'll wrap up with Q&A and discussion. Remember, if you have questions, drop them in the queue. We'll get to as many as we can during our session today, and we'll make sure to follow up with everyone after the webinar if we don't address your question during it. So real-time is defined in a lot of different ways. So today we'll talk about what it means at Molecula. So the definition of true real-time data is that it's accessible to the end user as quickly as it is gathered without having to pre-process it. This means that there's practically no delay between the time the data is created at the source and the time it's accessible to make a decision. And that access to the data is instant or in milliseconds. So there are 2 main components to the real-time data. So we have freshness, which is how frequently the data source schema should check for updated data from the connected data source. And then latency, and this is the delay between an action and a response to that action. So because of these 2 constructs, true real-time data allows any calculation, transformation, or joining of multiple sources to happen at the time the data is accessed, whether that's in a query, in a model, or in some code that is powering an application. So we know the world is moving faster and data is being generated, collected, stored, and used faster than it ever has been before. So it's no longer just analysts looking at your data. Sometimes the data is being pulled in straight from one application and then immediately served to another application. And that's when that first millisecond really matters.
So Erica, real quick on this point, Josh Tobin, the founder of Gantry ML, recently said at the Feature Store Summit that real time has not been necessary because advanced analytics and AI have been held to an academia standard. But as it gets productized and is responsible for making money, real time will be necessary. So what do you think about Josh's statements, and do you agree with that?
Oh, definitely. So anytime in my experience that you're moving from academia to industry, you're usually moving from like a research and development model to more of an operational model. And in my own career, this was a really big shift in how I had to think about things. And in a nutshell, it's one thing to develop an analytics product. It's a whole different task to bring that product full circle and put it into operations on an ongoing basis. So I think that that's one of the things that is hindering the ability of machine learning to move from that more academic focused world of research and development into really actually delivering that in the real world. I don't know, William, do you have any thoughts to add there?
Yeah, I think it's very true. I think a lot of things you can do on a small scale. You can build a system in a garage, you can build it on a local side. But when you're trying to actually bring it into the real world in production, there are millions of other things that can go wrong, and you need to be able to build that level of resiliency. That's one of the reasons why taking something from a proof of concept and a prototype into production is so challenging.
Absolutely. So despite all this effort to make real time a reality, it remains elusive for most companies. So Albert, you want to tell us why this is so difficult?
Yeah, absolutely, Erica. So real time is hard. I think we all kind of agree on that. And to get a background as to why, this is a framework that we use at Molecula for the data ecosystem. So we kind of break it up into 4 key steps: collection, storage, access, decision, and action. And each of these has a unique set of requirements and processes to support it. So for example, during the collection phase, data is scattered and distributed across devices. It must be collected and combined before it can be analyzed to deliver value. At the storage layer, data is stored in data clouds, data lakes, data warehouses, and databases where it has to be processed. So one of the key things I want to call out here is the pre-aggregation step in the middle here, which is particularly time-consuming and costly at this phase. Basically, that pre-aggregation step, that circle, makes real-time analytics very, very challenging in most cases. The next layer over is the access layer. So we view this as an infrastructure-based access layer, and this often takes 4 to 6 weeks on average to provision the data for a new project. So in production, queries at this layer typically take minutes, sometimes hours, depending on the data. And finally, the last layer, decision and action. So true real-time requires fresh, low latency data that can be computed at runtime so decisions can be made. And the current process makes it really, really challenging to perform this consistently and at the scale needed for many use cases. So William, Erica, just wanted to ask real quick, does this resonate with you? Is this something you've seen at a place you've worked before with customers? I'm just curious in your feedback here.
I'll say yes. So we're actually doing a similar type of a model. We go a step further and actually bring compute into the middle of collection in order to be able to build our network. But yeah, this makes a ton of sense.
Yeah, we were talking the other day about the actual physical distance that data needs to travel. And it was, even though I've been in this field for a really long time, like the closer I get to the technology side and the engineering side and kind of further away from that academic or analytics facing part of it, that's something I never really thought about. So William, can you talk a little bit about like data? It's not just this nebulous thing that's just in the air. It actually has to travel through cables. So that was something I wasn't really aware of. So can you talk a little bit about that?
Yeah, so what Subspace has actually found is when you're building a project and it's all on a single local laptop and you're able to design these individual steps, it's all nice and it's localized and contained. But we're actually finding in the real world where the data is being generated somewhere geographic, and the internet doesn't have a concept of effectively GPS directions. And so if you're doing analytics, let's say on a fraud use case as an example, these are transactions happening all over the globe, or at least all over North America, Europe, and places like that. And many times, the time from where that event actually happened on the collection side until it actually gets into the storage side can actually be larger than the time it takes to actually run the query to do any kind of an action on it. And Subspace is looking at it and saying, how do we reduce it to the point where it's the speed of light from wherever it happens to wherever you need it? And that's where the fun things where it crosses over with Molecula for us.
Yeah, absolutely. And William, that leads right into our next piece, which is, with this context in mind, let's take a brief look at how Molecula's format is the key ingredient to real-time performance.
Molecula reduces the dimensionality of data to its simplest form by collapsing conventional data models and abstracting the relationships in the data, creating a highly optimized feature-first data store that maintains data compression when queried, all without copying or moving the raw data itself.
So that goes by really fast. So I usually like to play it twice, just in case you missed something. So I'm going to play it one more time.
Molecula reduces the dimensionality of data to its simplest form by collapsing conventional data models and abstracting the relationships in the data, creating a highly optimized feature-first data store that maintains data compression when queried, all without copying or moving the raw data itself.
All right, so remember that we have freshness, so how up to date the data are in the database, and we have latency, the response time between an action and a response to that action. So historically, analytics have focused on reducing latency, so everything here on the right-hand side. And pre-aggregation that Albert talked about earlier, or taking your data and summarizing it for analysis, has been the workaround to minimizing that latency, but it comes at the expense of freshness. So as you just saw in the video, Molecula uses FeatureBase to collapse your data into a proprietary format that eliminates the need for the pre-aggregation, but allowing you to have ultra low latency and up to the millisecond freshness of your data without having to do that pre-aggregation. Another bonus is kind of a play on real time. You don't have any cold starts with FeatureBase. Once you have FeatureBase set up, you can immediately start using it for multiple use cases, and you're not waiting for pre-aggregated data that's specifically used for your next project. So not the real time that we're talking about in terms of Subspace or analytics, but it's another kind of cool feature of FeatureBase. So now that you kind of understand where we're all coming from, we're going to talk about a couple of real-time use cases that our customers are using to fulfill their real-time data using FeatureBase. So first, customer segmentation. As Albert mentioned earlier, Molecula was born out of solving a real-time customer segmentation problem, and it continues to be a very popular use case for many of our customers. So we currently serve several customers that are using FeatureBase to enable real-time segmentation, often for dynamic personalization of content. So sometimes they might be serving programmatic ads on websites, and these ads are personalized based on the information that's known about that user. So it's really important that all of that information is very up to date, especially kind of your online activity or the online behavior that you're doing, so that those very recent events that as you're scrolling or clicking on things as you're browsing, those can be used and tied back to you in order to serve up personalized content. So when customers are bidding on who is going to see these ads, they usually have about 130 milliseconds to win an ad bid. In this case, every millisecond matters, and FeatureBase allows our customers to take advantage of that first millisecond to deliver that personalized content. And I know 130 milliseconds is kind of like the standard. I know, William, we were talking the other day, you have some more information about that. So you want to weigh in on this one?
Yeah. So Subspace has actually been working with folks because that 130 milliseconds is how long from when the data hits the ad network. But we're actually seeing it also from as somebody's on their phone and they're starting to like scroll through and that ad is supposed to show, the request from that phone to the ad network can sometimes take more than that. And so even if the 130 milliseconds was considered really fast to do like the customer segmentation, a lot of that latency envelope budget could have already been spent when the network goes unexpected. And 130 milliseconds, just to give some example, that's just a little bit faster than the time it would take for data to go from India to the East Coast. So think about that in context.
All right, we have another special guest that is in my lap. Sorry. No, that's awesome. It's like it has a big implication for the analytics and the money that the customers are spending on their advertising as well, because you can win an ad bid and that's one metric. So how many ads did you win? But then were they really seen? Like, are you really taking advantage of your marketing dollars the way that you think you are? So customer segmentation, dynamic personalization, this is definitely one of the top use cases that we see for real-time data. Next, we have, hang on just a second. There we go. Albert, you want to talk about fraud detection?
Yeah, so real-time use case number 2 is fraud detection. And to kind of highlight this, I'd like to share a customer story. We are working closely with a financial services firm. They have more than 400 different financial institutions using their digital banking platform. So this platform obviously houses an enormous amount of secure, sensitive information about the 40+ million users of the platform. So modern network attacks, as we all know, require an increasingly complex infrastructure of intrusion detection, prevention software that's distributed across devices, much to what William was saying. And this creates enormous data stores that continues to grow. So the customer used FeatureBase as an overlay to their existing security solutions, and this allowed them to analyze high volume network data and begin to predict network intrusions in the milliseconds. So this is being done at scale with 100 million monthly logins events being captured and analyzed using FeatureBase. And so if we zoom out a little bit, let's consider how this impacts things. With that level of insights to potential fraud, it's providing a meaningful experience to customers, keeping their information safe and protecting this company's brand with their partners. So it has to be done at scale, in real time, and with the freshest data possible. So this is the poster child for a use case where real time matters. And with that, I really like to hand it over to you, William, and look and have a conversation with someone who looks at real time in milliseconds on a global scale.
Thank you. All right, so first off, what is Subspace again? Subspace is building a global infrastructure network to have the fastest network from any point on the planet to any other point on the planet. Subspace is about an 80% software, but still 20% infrastructure company. And we're building it so that this is the fastest from any 2 points. And we're trying to be able to see, can we get speed of light from any 2 random points between any 2 people internet connected? And so how do we do this? Or for what, we're doing it for these use cases. Some of these use cases here are existing use cases that we're able to adapt and work around the limitations of the internet. But some of these use cases can't actually become real without a better real-time network. For example, you can't have a remote video surgery going on and have a call drop and try and dial back in. You have to have a real-time network that you can actually trust and believe in, and one that can actually adapt to the chaotic internet weather that exists. Next up. So how does Subspace work? So at a really brief high level, Subspace is made for simple interfaces and easy to access to the network while we deal with all of the crazy weather complexities underneath. We have a packet accelerator that's a simple IP proxy. We have SIP teleport that makes it easy for call centers and other telecom providers to access. Global turn for anybody with a WebRTC use case, and RTP speed for anybody who's doing open source telephony. But underneath, what's actually happening is Subspace is using GPS synchronized clocks to be able to measure one-way latencies, basically as if it's a laser, between every single piece of fiber on the planet, building this huge graph in real time, sub-second, of what's the current network weather, and using that to go through and compute what's the fastest way for every person or machine to be able to talk to every other person or machine, however those 2 participants decide to communicate. And we're doing this with really, really sensitive low latency systems. And our goal is to be within 5 milliseconds of 95% of the global connected population, and that is a big challenge. And progressing, we're already at over 100 points of presence globally. That's the next one. We've built a company that is able to, next slide. We've built a company that's able to deploy a network and optimize a network faster than anybody else has been able to do. These are the locations that we've already deployed in, and some of the locations that, at least when the slide was made, were up on our roadmap. So Subspace has been building out network, and a month and a half ago, we were the 18th most interconnected network in the world. And in that month and a half, we're already at the 9th most interconnected network in the world. So there's only 8 more ahead of us. And this is the impact of what real-time actually provides to users. This is a chart showing an example of, these were gamers playing at 180 milliseconds, 220 milliseconds and higher. And these gamers were trying to experience the game, but it's nowhere near what the game was designed for a good high engagement experience. What Subspace has done is actually taken this blue distribution of the player latencies and actually turned it over to the green. So now you've got players playing as if they're in the same city as this game server, but they're not. The game server is in the same location, the player's in the same location. The experience is drastically better. And that's the Subspace effect.
So William, I want to make sure I understand this chart again. So you're saying like the latency across the bottom, you're saying that with the blue, it's kind of all over the place. It's like this kind of flattish distribution. And so it's just kind of all over the place, but you've taken everyone and you've like kind of stacked them over here to the left so that they're all getting that good gaming experience.
Yep, exactly. And so when the internet is actually performing in normal internet weather, you end up with people with this distribution. Because they've been slowed down so much, you get the smoothest distribution. We've actually optimized it to the point where you can see in the latency distribution chart actual metro areas. You can see people population as basis of how far they are, how many hundreds of kilometers they are from the game server, because the internet is so clean. You can actually measure that distance rather than have to assume.
It's awesome. All right, so that wraps up our scheduled programming, and we're going to take a few questions. I think we have time for a few of them. So let's see. The first one is, why are you doing this webinar together, and what does Subspace and Molecula have in common?
I can take a swing at it.
Okay.
Subspace is constantly talking to companies, individuals, gamers, and communities about real time. Gamers are a great example. Gamers understand that real time and latency really matters. If you're about to play with a team and you're trying to make a particular jump that has to be timed just right, but your character doesn't jump, and then suddenly you've died, and then it looks like it's trying to move, like that's a horrible experience. And that's one that people kind of like understand, especially if you've played any kind of multiplayer or cooperative game. And so Subspace, I'm looking at it as showing people that as we're getting more internet connected, as we're moving to remote first, as we're moving to many of these other types of use cases, or machine to machine even, that real time matters. And you can't control what you can't measure. And if you can't measure it, you can't actually action it. And so Subspace is looking at and trying to encourage people to think about the tools they're using to be able to handle things as fast as computers can do it, not just stay in the world of what humans are able to do.
That sounds right up our alley. So yes, and also Subspace is actually using FeatureBase for some of their customer-facing reporting. So with bringing real time to the market, that's how we're connected. And that's why we're all here today. Let's see. Another question. So how can someone interact with Subspace? So that is actually good. William, do you want to talk about how to get in touch with Subspace?
Yeah, so for the Subspace side of things, sign up on our website, subspace.com, either reach out to us on social, and we can help you get started. We have those 4 simple interfaces for developers and companies trying to be able to build and service players. We do not yet have a business to consumer product, but we've had a lot of end developers who are like, you know what, I can put something together for myself, and they've been able to solve many of their real-time challenges. So subspace.com.
Awesome. And for Molecula, very similar. If you would like more information or, you can always request a demo on our website or reach out to us on social media as well. All right, let's see. I think we have time for one more question. Let's see. So this says, so you're talking about real time and no cold starts was mentioned. What is the timing to get data set up with Molecula? And what happens like with my data? Will it update in real time? Let's see. So I think the answer to this would also be to request a demo. We understand everybody has a different data environment. Everyone is unique. So we have a stellar customer success team that works with you on your implementation. We've had some that are done in 45 days. We've had some that have been done faster. It depends on a lot of things like the availability of your team, how complex your environment is, how much data there is to map, etc. So the best way to learn more information is really to just reach out to us on our website and request a demo. All right. Any last thoughts on real time before we wrap up?
Let's count all those milliseconds.
Yeah.
Awesome. Well, thank you, William, for joining us today. This was a really fun session. I've really enjoyed talking with you. Thank you for everyone that attended the webinar. Look for our next newsletter or webinar announced on social media and on our website, and we look forward to the next one.
Awesome. Thanks, everybody.
Thank you.
Thanks.